Hello everyone, and welcome back to the Fluctus Channel. The F-35B Lightning II was built for the Marine Corps' most demanding kind of aviation. Operating advanced stealth aircraft from amphibious assault ships, expeditionary bases, and short runways close to the fight. Unlike the F-35A used by the Air Force or the carrier-based F-35C used by the Navy, the B model can take off in a short distance and land vertically. That ability comes from a lift fan behind the cockpit, a swiveling rear nozzle, and roll posts in the wings that help balance the aircraft during vertical recovery. This special design gives the Marines flexibility, but it also creates trade-offs. The lift system takes internal space that the other F-35 variants can use differently. And that affects fuel, structure, and weapon arrangement. One major difference is the gun. The F-35A carries its cannon internally, but the F-35B uses a belly-mounted gun pod. Hidden below the fuselage, the pod contains the 4-barrel, 25mm GA-U-22A cannon, giving the jet a close air support option without redesigning the lift fan airframe. The gun pod may look small compared with the aircraft, but it adds a very specific capability. Missiles and bombs can strike from distance, but a cannon gives pilots a direct, fast, controlled weapon for strafing runs against targets on the ground. It can support Marines under pressure, attack light vehicles, or engage exposed positions when the situation demands close precision. Carrying the gun externally also means maintainers can inspect, service, and remove the system as a mission package. The first airborne firing of the F-35B gun pod marked an important moment for Marine aviation. Test pilots lined up the aircraft, stabilized the flight path, and fired measured bursts to check how the pod performed in real air conditions. Engineers had to confirm vibration, accuracy, recoil, airflow effects, and software integration. A stealth fighter firing a gun is not just about pulling a trigger. The aircraft's computers, sensors, pilot displays, and weapon controls all have to agree before rounds leave the barrel. During strafing runs, the process becomes even more disciplined. The pilot enters the range pattern, identifies the target area, sets the attack angle, verifies clearance, and lines up for a firing pass. The aircraft descends quickly, the pipper settles, and the gun fires in a short burst before the jet climbs away. Range safety teams, ground observers, and aircraft crews work together so every pass remains inside the approved lanes. The F-35B's weapons story reaches beyond the gun. Nighttime ordnance loading with Marine expeditionary units shows crews preparing the jet under low light, using helmets, lights, checklists, weapons carts, and strict safety calls. Before a weapon is loaded, it is inspected, moved carefully under the wing or into position, raised, connected, and secured. Arming crews verify pins, lugs, cables, guidance surfaces, and release mechanisms. Everyone moves deliberately because one mistake around live ordnance can endanger the aircraft and the deck. The aircraft's early GBU 1-2 separation testing also showed how the F-35B had to prove that bombs could release cleanly from the airframe. A 500-pound laser-guided bomb does not simply fall away. Airflow, speed, angle, and aircraft geometry must allow it to separate safely before guidance begins. Those tests helped build confidence that the jet could carry precision weapons while preserving its unique short takeoff and vertical landing role. Hot pit refueling and forward arming points add another layer. At Kadena and in expeditionary hot load operations, crews refuel or load aircraft while keeping turnaround time short. Ground teams approach carefully, connect hoses, manage static grounding, watch for fuel leaks, and keep fire response ready. The goal is speed without carelessness. For the F-35B, that means a stealth fighter can land, reload, refuel, and return to the mission from austere locations instead of depending only on major air bases. This is why the pod matters during expeditionary operations. Marines can keep the aircraft configured for stealth and sensor work, then add the cannon when the mission calls for closer support. Each round, burst, and angle must still be tested, because a fifth-generation jet has to balance firepower with flight control. That careful testing turns a belly pod into a dependable combat tool fast. The F-35C was built for a different battlefield. The flight deck of a U.S. Navy aircraft carrier. It has a larger wing, stronger landing gear, folding wingtips, and a reinforced structure designed for catapult launches and arrested landings. Its wingspan is about 43 feet, noticeably wider than the F-35A and F-35B, giving it better low-speed handling during carrier approaches and more range for long missions at sea. Before launch, flight deck crews move through a tight and dangerous choreography. Sailors check tie-down chains, remove covers, inspect weapons, signal pilots, clear intake areas, and position the aircraft on the catapult. The pilot completes cockpit checks while directors guide the jet inches at a time through a deck crowded with other aircraft. Tractors, fuel hoses, blast deflectors, and personnel in colored jerseys. Every hand signal matters because jet noise can drown out voices. The danger of F-35C carrier operations comes from the environment itself. The deck is moving with the sea. Engines produce powerful exhaust. Spinning intakes can pull loose objects inward, and aircraft may be launching and recovering only seconds apart. Sailors stay low, move fast, and trust procedures built from decades of hard lessons. A dropped tool or loose fitting can become foreign object debris, so the deck is constantly inspected. Catapult takeoff compresses enormous force into a few seconds. The aircraft is attached to the shuttle, the holdback fitting restrains it, the pilot advances power, and the shooter gives the final signal. When the catapult fires, the jet is thrown forward and reaches flying speed before leaving the bow. Recovery is just as unforgiving. The F-35C lines up on the angled deck. The pilot follows landing cues, and the tailhook aims for the arresting wires stretched across the landing area. When the hook catches, the aircraft stops violently in a short distance, then folds back into deck movement as crews rush to clear the landing area for the next aircraft. The F-35C brings stealth and sensor fusion to carrier aviation, but its daily survival still depends on sailors who can launch, recover, fuel, arm, and repair jets safely on a moving runway at sea. The larger carrier wing also helps during approaches at night or in poor weather, when small corrections decide whether the aircraft settles safely or waves off. Each launch and recovery is rehearsed around fuel state, deck status, and the next aircraft waiting behind it. The A-10 Thunderbolt II, on the other hand, belongs to a different era of combat aviation. But its gun remains one of the most feared aircraft weapons ever built. The jet was designed around the GAU-8, A Avenger, a 7-barrel 30mm Gatling cannon built for close air support and armored target attack. Instead of adding a gun to an aircraft, engineers effectively built the aircraft around the gun, placing the cannon along the center line, so recoil forces aligned with the airframe. The GAU-8 is enormous by fighter standards. Its barrels, feed system, drum, and ammunition link the nose of the aircraft to the entire mission of the platform. The weapon can fire around 3,900 rounds per minute, sending heavy depleted uranium or training rounds toward targets. With a sound that became closely associated with the A-10, against tanks, vehicles, and hardened ground targets, the cannon gave the aircraft a close-range attack identity that missiles and bombs never fully replaced. A-10 strafing runs show how this weapon is used in practice. The pilot enters the attack pattern, rolls toward the target, descends into the firing line, and squeezes off a controlled burst before pulling away. The aircraft is slow compared with modern fighters, but that works in its favor during close air support. It can stay near friendly troops, turn tightly, and make repeated passes while carrying bombs, rockets, missiles, and the cannon. Keeping that gun ready takes serious maintenance. At Osan Air Base and other armament shops, maintainers remove panels, inspect barrels, check feed components, clean parts, measure wear, and verify that the firing system remains safe and reliable. The GAU-8 is not treated like a simple accessory. It is a major aircraft system, and crews work day and night to keep it functional for future missions. Gun installation is a careful process. The cannon must be aligned, lifted, guided into the aircraft, connected, secured, and checked before the A-10 can return to service. Maintainers use equipment, checklists, and teamwork to control the weight and geometry of the system. If alignment is wrong, accuracy and safety can suffer, so the installation is handled with patience. Loading the A-10's ammunition is equally detailed. Crew members position the loader, feed rounds into the system, inspect the beltless feed path, and confirm counts and safety conditions. In cold or desert training environments, reload teams still follow the same standards, because the gun is only useful if it feeds smoothly when the pilot fires. Bomb loading expands the aircraft's role. Armament technicians prepare pylons, inspect suspension equipment, raise munitions, connect wiring, and verify release settings. The A-10 can carry guided bombs, rockets, and missiles, but the GAU-8 remains its signature weapon. Target practice displays this mix of firepower, combining strafing with other weapons to prepare pilots for close support missions. Seen beside the F-35’s potted 25mm gun, the A-10's Avenger shows two different ideas of air power. One is a stealth aircraft that carries a gun pod when the mission requires it. The other is a rugged, close support aircraft built around a massive cannon from the beginning. Both depend on maintainers, loaders, pilots, range teams, and procedures that turn metal, software, fuel, and ammunition into controlled force. From the F-35’s hidden gun pod to the F-35’s carrier routine, and finally, the A-10's Avenger, every burst of fire begins with disciplined maintenance and teamwork, long before pilots press the trigger in combat. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.